So all that's left now is to finish up the problem. And also we might want to consider that this x also is on a specific domain. The smallest x can be 0. We've just seen the largest x can be as 25. Arguably, since the x can't really be 0 and the x can't really be 25, or we wouldn't have a triangle at all, the interval is open, therefore has no endpoints. But we can also sort of, realize that here's 0, here's x equals 0, here's x equals 25, and the only critical point is at 5 over square root 2, and that is a max. So the rest of the graph has to look like this. Right, and then we're excluding the endpoints. But since we weren't asked for a minimum value, there's no other maximum value. Therefore, we don't need to consider the endpoints because there's only one. If we had endpoints at the interval, and there was more than one critical point, we might need to consider whether the max that we found was really the max on the interval because maybe the function goes back up. All right, but we know we don't have that. We only have one critical point, therefore the only possible max, the only critical point that we have has to be the max. It's a global max. All right, so, but what else should we be considering in number 7? We should be reading the question to see if we need to solve for any remaining variables. What we got is A has a max at x equals 5 root 2 over 2. Now we can use our knowledge of the 45, 45, 90 triangle and say, now I know the y is also 5 root 2 over 2. But what if I didn't know that? So let's be on the right page, shall we? I think we're on page 226. That's what I get for grading homework while I'm doing my videos. It says we want the area and the dimensions. So that means I need x, y, and the area. All right, so suppose I didn't know it was 45, 45, 90 triangle. Maybe I didn't notice that yet. All right, so then I'm going to say I knew that y was equal to square root of 25 minus x squared. So that is going to be square root of 25 minus, so if I think of the x as being square root of 25 over 2, then x squared is 25 over 2. So y is the square root of 25 over 2, which we already know is 5 root 2 over 2. So y is also 5 root 2 over 2. All right, so the dimensions are x equals 5 root 2 over 2, and y equals 5 root 2 over 2. Now I've written these here, but let's put them together and then put it together with our answer. Our answer is 1/2 x times y. Our area, is 1/2 x times y. So that's 1/2. Again, it will profit me to write this as square root 25 over 2, because that way I'll be able to see clearly right away without doing too much work that the product of these is 25 over 2. So my area is 25 over 4, which actually makes sense if you think about that 45, 45, 90 triangle, right? And this is 5. So suppose you built a square that was 5 by 5, right? Then this would be a quarter of the area of that square. So this problem also illustrates a property that you're going to see a lot, which is that the shape that encompasses the largest area is going to tend to be the most symmetrical one. So we're going to see that going forward. All right, that is number 2. Let's see about number 4, shall we?